this is Geometry Lesson 9.2, developing formulas for circles and regular polygons. We've learned about circles here. A circle is a locus of all points in a plane that are a fixed distance from a given point, called the center of the circle. You got the radius, the diameter. Formula for a circle for the circumference is 2 pi r, and then the formula for the area of a circle is pi r squared. You can also use pi d for the circumference as well. All right, find the radius of circle J if the circumference is 65x plus 14 pi. So we're going to set 2 pi r equal to 65x plus 14 pi. Well, if I have pi on both sides, that can cancel out. And then I'm going to divide both sides by 2. So the radius would be 32.5x plus 7, and you would leave it like that. You can't do anything else with that x. Find the area of circle A in terms of pi, which is the circumference of 4x minus 6 pi. So once again, we're going to have to find the radius again so we can find the area. So the pi would cancel, divide by 2. So 2x minus 3 equals the radius. Well, pi times 2x minus 3 squared, and that's good enough. You can leave it like that, meters square. If you would FOIL that out, you could do that as well, but you can leave it like that for these problems on this. All right, the pi key always gives you your best approximation on your calc. Don't round until the last step. So a pizza making kit makes baking stones with circular baking stones with 3 different diameters. Find the area, round to the nearest tenth. So we take, now those are the diameters. So it's pi times 12 squared, pi times 18 squared, and pi times 24 squared. So if you want to do that in your calculator, what do we got here? 24 pi, 452.39. 1017.88, and I think you get the idea here. Use that pi key on your calculator, 18.0956, and all those would be centimeters square. All right, so once again, follow along on the formula sheet if you're not sure on these for Chapter 9. All right, the center of a regular polygon is equidistant from the vertices. The apothem is the distance from the center to a side. A central angle of a regular polygon has a vertex at the center, and its sides pass through consecutive vertices. Each central angle measures 360 divided by n. All right, so if you're looking at a regular pentagon, this would be the apothem right here, distance from the center of a side to the center of the polygon. Okay, we can only use this stuff with regular polygons, but if you wanted to find these angles, you would take 360 divided by 5, which would mean each one of these would be 72. And then if you wanted to go down even more, you could divide that by 2 to get 36. Okay, so how to figure out all that stuff to use this for area. So then you have 5 triangles. You take the apothem times the perimeter, and it leads us to the formula for the area of a regular polygon, which is on your formula sheet. Half the apothem times the perimeter. We are going to be using a little bit of trig with this stuff, so make sure you have your calculator set into degree mode. All right, let's walk you through how to do one of these. Find the area of a regular heptagon with side length 2 feet to the nearest tenth. So heptagon is 7, so we have 7 sides. So there's 7 of these triangles in there, and it says the side length is 2 feet. Okay, this line right here would be our apothem. All right. So we're going to go half times the apothem, which we're trying to find, we don't know that yet, times the perimeter. Well, 7 times 2 would be 14. All right, to find the apothem, you got to find your angle up here. Well, we would have to find that angle and then do some trig. So we take 360 divided by 7, and then we're going to divide that by 2. 25.71 is that angle. Okay, Well, if this is 2, then this would have to be 1, right? The whole thing is 2, so half of it is 1. So that's opposite and adjacent. So that's tangent. So tan 25.71 equals 1 over A. So A is on the bottom, so we take 1 divided by the tangent of 25.71, which gives me an apothem of 2.08. So now I can do that. Half times 2.08 times 14, which gives you an area of roughly 14.56 feet squared. So make sure you know how to find those apothems. Let's try another one. All right. Find the area of a regular dodecagon with a side length of 5 to the nearest tenth. Dodeca is 12. So that's 12 sided. So there's 12 of these triangles. All right. Side length this time is 5. So we're going to go half times the apothem times the perimeter, which would be 60. 12 times 5 is 60. So we have to find the apothem. So that's 2.5 down there. Well, we got to find our central angle. So 360 divided by 12 is 30. Divided by 2 is 15. So our angle is 15. So we're going to go tan 15 equals 2.5 over A. Okay, so I take 2.5 divided by the tangent of 15, which is an apothem of 9.33. So we go half times 9.33 times 60 gives me an area of 279.9 centimeters square. So make sure you know how to find that central angle, and then you got to use some trig, and half times apothem times perimeter is the formula for a regular polygon. All right, let's try one more like that, except this time we'll do this one because they gave us the apothem, so we need to find the side length. Okay, so half times the apothem times the perimeter. Well, we can see 1, 2, 3, 4, 5, 6. That's a hexagon, so that's got 6 sides. Okay, so 360 divided by 6, 60 divided by 2 is 30. So our angle up there that we're going to use is 30. So we need to find x. Well, that'd be tan 30 equals x over 14. So this time I'm going to multiply 14 tan 30, which gives me 8.08 from here to here. But I'd want to multiply that by 2, which would mean my side length would be 16.16. Okay, then I have 6 of those, so take that times 6 to get my perimeter, which comes out to be right around about 97. So half times 14 times 97, 679 inches square.